Everyone, welcome back to my channel. Today we're going to work on the question longest common subsequence. It's a medium level question and the question states, given two strings text1, text2, return the length of their longest common subsequence. If there's no common subsequence, then return 0. A subsequence of a string is a new string generated from the original one with some characters. Can be none deleted without changing the relative order of the remaining characters. So for example, ACE is a subsequence of ABCDE. As you can see, we deleted the B and the D, and then it creates ACE. So example 1, it's the same one, so the common subsequence is 3. And then ABC equals ABC, so common subsequence is also 3. ABCDF, there's nothing in common. There's no way you can delete to make these two equal, so it's 0. This is a pretty popular DP question, and as with other DP questions, I like to solve it top-down using recursion. So all DP questions use memorization, so we're going to use the Python decorator cache for our memorization. And let me define our DP function. So it's going to take pointer 1 and pointer 2. Pointer 1 will be used for text 1, and then pointer 2 will be used for text 2 to go through each character of the text. And like other DP questions, there will be a base case. Our base case will be to see if our text is exhausted, either text 1 is exhausted or text 2 is exhausted, then we return 0 because we're at the end. If pointer 1 equals length of text 1, or pointer 2 equals length of text 2, then we can just return 0. And now we can finally start writing our recursion case. There are two recursion cases. So for our first one is if our current pointer is a match. So if we have match, recursion case 2 is if we don't have a match. So looking at this example 1, currently pointer 1 is at A and pointer 2 is also at A, so they're a match. And what do we do when they're at a match? We want to increase our the common sequence number, right? So that's gonna be counted in our recursion directly. So if text 1 pointer 1 equals text 2 pointer 2, then we want to add 1 to our common sequence and return 1 plus TP pointer 1 plus 1 pointer 2 plus 1. In this case, if they're equal, we want to move both of the pointers to the next one because we know we already accounted for the first letter. So we move our pointers for both of them. And then if in the second case, after we moved, so in this example, now we're at pointer 1 is at CE and pointer 2 is at BCDE. And C and then B does not equal each other. Actually, we can just do else. If they do not equal each other, what do we want to do? We can return the match between TP pointer 1 plus 1 pointer 2 doesn't move, or TP pointer 1 doesn't move and pointer 2 plus 1. The reason we do the match between either moving pointer 1 to one letter ahead, or we move pointer 2 to one letter ahead and pointer 1, is they can generate different results depending on the case. So looking at this, for example, we're currently pointer 1 is at CE, right, and pointer So pointer 1 is at C and pointer 2 is at B, C, D, E. We can either move CE to point at E, or we can move B, C, D, E to point at C, D, E. So in the first case, if we move pointer to E and then we keep the second pointer at 2, then we miss this opportunity of C matching here, right? So it's better we generate a greater common subsequence if we skip the B and move pointer 2 to the next one. That's why we need to find the max of these two cases. So in the end, we have to call this dp function, so we return dp. And we initialize both pointer 1 and pointer 2 at 0. So this is how I would solve this question, and as for the time complexity and space complexity, they're both m times n. M would be the length of text 1 and n would be the length of text 2. Let me know if you have any questions, and thank you so much for watching.